We're surrounded by amazing things. Sleek cars, custom medical implants, but we almost never get to see the incredible inventions that actually make them possible. Well, today, we're going behind the scenes. We are diving deep into the patent for a machine that could totally reshape how we build the world around us. Let's get right into it. So let's start in the world of modern manufacturing. Just imagine you need one single unique metal part. Maybe it's a custom bracket for a prototype car or a perfectly fitted implant for a patient. For years, making just that one part was a massive, expensive nightmare. And that really gets us to the core problem, right? The old school way of doing things meant you needed these huge, dedicated molds or dies. And making those is just unbelievably expensive and takes forever, especially if you only need one or two parts. So what's the solution? Well, the answer is this really brilliant process called incremental sheet forming, or ISF for short. Now, instead of stamping a whole sheet of metal in one go, ISF uses a simple, rounded tool, kind of like a ballpoint pen, and it follows a computer-controlled path to just gradually and gently shape the metal. It is incredibly flexible. This slide really lays it all out. On the left, you've got the old way, slow, super expensive, and only really makes sense if you're churning out thousands of the exact same thing. But on the right, you have ISF, low cost, flexible, and absolutely perfect for prototypes and custom one-offs. It's a true game changer. But ISF isn't perfect. To get even more control, engineers came up with an advanced version called two-point incremental forming, or TPIF. The two-point just means it uses a tool on top and a little support on the bottom. It should have been a huge leap forward, but it came with a critical hidden flaw. See, on paper, TPIF looks fantastic. You can make these incredibly intricate shapes with it. But in the real world, as the patent itself points out, the process has this one hidden issue that has pretty much stopped it from being widely used in the industry. So here's the deal. When the forming tool pushes down, the sheet of metal is clamped so tightly that it can't really flow into the area that's being shaped. The result? The metal stretches, and it gets dangerously thin. It can also spring back, which just ruins the part's accuracy. And these are the very problems this new invention was created to solve. And that brings us to the hero of our story, the invention itself. This is an apparatus designed specifically to tackle those critical flaws and finally unlock the true potential of two-point incremental forming. And here it is. I know, at first glance, it just looks like a complicated frame, but believe me, every single part of this machine is engineered to fix the problems we just talked about. This is the device that wants to revolutionize custom metalwork. This quote from the patent just cuts right to the chase. The entire goal here is to enable material flow. So instead of stretching the metal until it's thin and weak, this machine is designed to actually feed the material into the forming zone as it's being shaped. It's brilliant. So how does it actually pull that off? Come on, let's pop the hood and take a look at how all the key pieces of this incredibly clever design work together. Okay, this diagram gives us a fantastic bird's eye view. You can see the top frame, the base frame, and all the gears and screws and wheels that make the magic happen. We're going to break down the two most important systems right now. First up, the most important component, the top frame, which is labeled here as number 30. This thing is the absolute heart of the invention. Its job is to hold the sheet metal, but, and here's the crucial part, it's not just a static clamp. It's dynamic. It's designed to precisely move and control the sheet during the process. And this is just genius. Check it out. An operator turns the hand wheel, that's number 14. That turns a belt, which rotates two long lead screws, number 16. Now, these screws have threads going in opposite directions, so as they turn, the blank holders, that's number 18, slide smoothly inwards, feeding the sheet metal right where it needs to go. That's how it prevents the thinning. It's such a beautifully simple mechanical solution to a really complex problem. All right, so solving the material flow problem was challenge number 1. The second key innovation is the base frame and its vertical support system. This whole part of the machine solves another subtle but absolutely critical issue, the machine's own weight. You see, you really don't want the heavy top frame pressing down and messing with the delicate forming process. So these vertical lead screws, number 34, allow the entire top assembly to move up or down. This system basically supports its own weight, making sure the only force on the metal is from the forming tool itself. And that means you get much, much greater precision. So we've seen how it works. We've gone through the mechanics. But what does it all really mean? Why should we care about a more precise metal forming machine in the real world? Well, the payoff is huge. By solving those thinning and weight problems, this device lets you make parts with incredible accuracy but at a much lower cost. It opens the door for easy customization, for automation, and it seriously cuts down on wasted material. It just makes the whole process faster, cheaper, and way more reliable for actual industrial use. And all of this leaves us with a pretty fascinating thought. As technology like this gets better and more refined, we get closer and closer to a world where making a single, highly customized metal part is as simple as just sending a file to a machine. So what are we going to create when that kind of power is accessible to everyone?